All right, so let's go through 5-minute quiz 21. We're going to try to just go as far as we can possibly go in this. So answer the following questions about gases and assume at STP. Well, that's going to be very critical because if you don't know what STP is, you're not going to know what any of this is. So what is STP? At standard temp and pressure. Well, here's the issue with that. What is it? All right, let's start there. That's a good point. Now let's start with temperature and pressure. So the temperature is 0 degrees Celsius or 273 Kelvin. Now, why is that different from standard conditions? If the weather conditions in this room were that, would that be good or bad? It would be really bad. That's 32 degrees Fahrenheit.
That wouldn't be.
STP is a lot different than standard conditions. Why they chose to make them different, I don't know, but it drives me insane. But they did. There's a little difference. Now, what is the pressure? 1 atm. Now, Parker, you brought up a very, very interesting point. If we're talking about moles and volume, 1 mole is equal to how much volume? Very good. 22.4 liters. That's very key. So anytime that you can do a mole-to-mole conversion or a liter-to-liter conversion, you can use this 1 mole at 22.4 liters. Have you watched the gas video package yet? If you watch that, it's all about it. That's the whole entire basis of that entire gas chapter. Is that right there? Okay? All right, so now that we know that, so then we can look at this. Answer the following questions. Number 1, the gas that has the lowest molecular velocity. Now, what's another way to say velocity? Speed. How does speed relate to molecules? Not size. Mass. Mass and velocity are related here. So how would you know which one is the lowest? Not largest.
The most weighted.
The most weighted.
I was trying to think of
The highest mass. All right, well, if we look at neon, what's neon's mass? Ooh, we need a periodic table, don't we? Canada, do you mind getting the green ones? It's about 20-something. Xenon is... I'll tell you what, just get the... I think that is a safe guess, isn't it? I'll tell you what, I'll just look. It is B. All right, so B is that. I'd still want to know. Oxygen is 32. 12.01 plus 16 is 20.
12.01 plus 16
is 28. 28.02. And then 14.01 plus 16
is 30. Wait,
yeah.
30.01?
Yep. 30.01. And then what is xenon? Can throw that number at me real quick?
It's that one.
131.29.
By a smidge.
All right, so 131.29. So here's the deal. So that's B. Which one of these has the lowest density? Now, what is density? Mass divided by volume. Since they are at STP, do they take up the same amount of space?
It's mass. No,
That's what I said.
not weight.
Mass. The volume is going to be 22.4 for all of them if we have 1 mole of each one of them. We're just going to assume that because it says at STP. So we need to know the number that is the lowest to have the lowest density, correct? Which would be what? We'll double check.
20.
Neon
is 20, right?
That doesn't make... What, is neon 20?
Yeah, 20.18.
It actually says the answer is D. D is a dog.
CO, wow. 28.01.
That doesn't make any sense.
That makes no sense at all. They're wrong! Well,
I kind of disagree.
well, density...
All right, we'll move on. Has the slowest rate of effusion through a pinhole. So if all of us were going to try to fit through the tiniest opening possible, who would fit through the easiest? The smallest person. Teresa, Cannon, y'all are up for debate. Okay? I would probably fit through the most difficult, so I am the largest. So effusion kind of has this relationship. It is the square root of the molar mass of the heavier divided by the molar mass of the lighter. That's just kind of the rates of effusion. So what we would do is we would compare these. So really the heavier mass is always going to effuse the slowest. So which one has the heaviest mass?
Xenon.
It is xenon again, so it is B. It has nothing to do with the molecular structure. It's everything to do with the mass. So effusion, again, has to do with the mass. And effuse is like a pinhole. Like if you're spraying cologne, if you're spraying an aerosol, it's how fast the molecule exits that pinhole. It's how you're relating them. It would give you a ratio. So if you're comparing the two, it would be blah, blah, blah is slower, this many times slower than the other. Okay? The gas that behaves most like an ideal gas. First of all, what are the good gases? Noble gases. Okay? There's less IMFs. Which one would probably be the most ideal? It is A, because it's smaller. And I want you to make this little note. The higher the mass equals, and this is a new word for you, more polarizable. Now, what in the world does that mean?
More able to be polar.
Okay. Why is it more able to be polar? Xenon has how many electrons? 10? Sorry. Neon has 10. Xenon has how many? 54. So, if you've got 10 electrons running around, or 54 electrons running around, which one's harder to contain? Xenon, which means it's able to kind of flip its charge a little easier, so you can pull those electrons. Remember we talked about this word yesterday? I think I just misspelled that. Shielding. I before E except after I don't know.
Actually, it's really E before
Okay.
I with a bunch of other cases.
Who cares? So shielding is that word. Xenon has all those orbitals in the way, and so it's hard to hold on to those electrons. So the higher mass is more polarizable. So that's kind of why it's less ideal. And then the gas that is least like an ideal gas would be, you got to find the one that's most polar. Least is most polar. What? Yeah, it is. Okay, it is. Which one of these would be the most polar? Most polar. You agree it's A and B are out. C is out.
I think it's D.
Well, which two have the greatest difference in electronegativities?
C and O, because C is farther away from O.
Exactly, because C is farther away from O, so it is going to be D. Does that make sense? You with me?
The answer choices weren't you. That really bugs me.
I'm sorry. Okay, we all good on those? All right, moving on to 6 through 10. As soon as you see this word right here, what color do you have? You don't have to do it. You don't have to know any of the colors. I think this one right here, though, let me double check.
So they're not going to ask about this?
No, they will not. Yep. I know that copper 2 is a blue color. Do you want the answers just to know them?
Yeah, sure.
All right. It is A, C, D, E, B. A, C, D,
Oh, yeah, 'cause
E,
manganese.
B.
Manganese is purple, or
Yep.
permanganate's purple. So.
Manganese is that purplish color.
Yeah.
D.
Yeah. Cobalt blue.
Nickel is green. Yeah, I remember nickel being a green. Lead is definitely a yellow color. I knew that. I know some of them, not all of them.
Wait, is that
Okay. All right. Next question.
so that copper is iodized with nickel? Is that why it's green?
All right. What's the good news about first part of? Okay. Go. Say it again.
So was the statute of
All right. So which ion is present based on the color? Well, I know that copper. So E is 1. Iron 3.
2 is A.
It's 2A,
Yep, 2 is A. Very good, because that permanganate. Remember, this is an indicator, and I know that I'm throwing a lot at you. You don't have to know colors, but permanganate is an indicator color. Light green is very good. D, nickel. Pinkish color,
Would that be A again?
it is C. And then orangish, reddish, yellow is the
Iron, right?
iron. Iron 3, though. Iron 2 is rust. Iron 3 is a little yellowish. All right, but we're good there. So let's move on to these. Teresa, what are these things called?
Pressure over temperature.
No, these are the butt diagrams. Remember? Okay. Because between the butt cheeks, what comes out? Gas comes out. Okay. Now,
That's so weird. Like,
they were here to hear all this. Y'all missed all this. Okay. At low. Now remember, temperature is low. Over here, temperature is high. So where would the solid be? The lower temperature or the higher temperature?
the lower temperature.
So that's solid and that is liquid. Now, these are called phase diagrams. These are out. You will not be tested on them. So I'm not going to spend time on them. The states of matter, yeah. At which point can all three phases coexist at equilibrium? What does that make sense? Where would that be?
AC and E.
I'm going to look at number 7. At which point can all three coexist? It is B. Very good. That is called the triple point. Why is it triple point? Because all three are there. That's called the triple point. Which point is closest to the critical temperature? I'm going to be honest with you, I don't know. Which point represents the only solid phase in the substance? That's easy. That is A. Which point is the substance of a gas? It is D. Very good. Does that make sense?
So the phase is off of the lines? Like, so
Yes.
that's the same
It is a solid, yeah. And then at which point of the diagram corresponds to equilibrium between the solids and the liquids?
E?
Solids and liquids.
E.
C. Yeah, see how they're easy. You just got to know the butt diagrams.
Why aren't they tested or something?
They say it's prior knowledge.
Prior knowledge.
Yep.
What do we?
Exactly. All right. I really have a feeling you're going to see one of these. Remember this, and I'm going to write this up here at the top. This is quiz 23. The slopes are the states. The slopes are the states. The slants are the phase changes. Excuse me. No. The flat. The flat is the phase change. My apologies. The flat is the phase change. All right. Now, if we talk about temperature, you've got to kind of pay attention to this. In comparison to temperature versus energy, which state of matter would have the least amount of energy?
Solid.
So where's it going to be? Between what 2 points? A and B. So that's going to be a solid. So where's the next slant? What do you think it's going to be? It's going to be liquid, and the highest one is going to be your gas phase. All right. The substance begins to boil at this point. Now, what is boiling?
From a liquid. Solid to liquid.
Liquid to gas. So at what point does it begin to boil? All right, very good. It is D. Okay. The substance is only in one phase at this point. The substance is only in one phase. Yeah, it has to be A. Why? It's not in a flat line. It's not in a transitional state. The substance begins to freeze. Now, what's occurring at freezing? Dang, Parker, you're off. Okay, so it begins to freeze.
Yeah, so it'd be B, right? Or would it be C?
It's C. It's beginning to freeze.
Yeah.
Okay? The substance begins to melt. What's happening with melting? Solid to a liquid. It's beginning to melt.
B.
B?
Because it's B.
Yep.
B.
No, just the point. The substance has finished its transformation from the solid to the liquid phase at this point. Very good. Do y'all see how easy these are? Don't mess them up. The hardest part is just knowing where the solid, the gas, and the liquid are. And it has to do with the temperature and the energy. Okay? Very easy. All right. We're gonna have to talk about these for just a minute. Stop it. I wish he would never said that. Refer to the following description, the different bond types of solids. Okay, the lattice of positive and negative ions held together by electrostatic forces. Guys, you've got to get this. It's a cation and an anion.
So
It's a Metal and a non-metal.
So it's
6 is A. That makes sense? I'm actually going to do this one backwards. You see how I'm kind of doing this one? I'm reading the answer choices and narrowing it down. That's a little easier to do.
I think it's weirder.
Weird. Okay. Closely packed lattice with delocalized electrons throughout. What is that called? The sea of electrons. It's a metal. So, hold on. Am I the right one? Yeah, okay. So make sure. So 7 is B. A strong single covalent bonds with weak intermolecular forces. Now, what is the weak intermolecular forces referring to? So which one up there would have an LDF and why? Methane. Why? Because methane is all nonpolar, right? So it has to be that one. So that one is C. All right. Strong multiple covalent bonds, including pi, with weak intermolecular forces. That is 8. Very good. So that is both. Yes, pi bonds are double bonds. And if you look at carbon dioxide, it's C double bonded to O. And remember what did we say about that? The plane is empty. The plane, and it's going to kind of bond like this. The way they said, the way to remember the pi bond is you always want 2 pieces of pi. You always want 2 bonds for pi bonds.
So would that still be a linear bond even if it's bent like that?
Yes. It's not bending, it's just arching. All right. Macromolecules held together with strong polar bonds. Macro means really big.
So, where's that balloon thing? That's macro.
I don't know. That's a balloon. Macro means diamond. It is E. All right. We good on all those? All right. 24. Ooh, starting to get into some buffers and acids and bases. Yay. Ooh. Let's just see if we can figure it out. A solution with a pH less than 7 that is not a buffer. Ouch.
Less than 7.
All right, so let's look at number 1. A solution initially prepared by 1 molar NaCl and a 1 molar HCl. Guys, is NaCl a salt? A salt is a buffer. So that knocks that one out, right? Okay. Number 2, an NaCO3. What is that? That is a salt. You with me? Okay. Look at the next one. You've got acetic acid and then sodium acetate. That is a salt. They're all salts.
So that means A is one of the answer choices that is.
I'm gonna be 100% honest with you. Buffers is not my thing. So here are the answers. A, D, B, C, and E. Guys, if y'all have a review book, if y'all want to watch some videos on buffers, go for it. I do not understand buffers.
I always find it funny how Miss Hicks says you'll never say anything.
I admit always when I'm wrong. She's just, to her I won't. To her I won't. All right, it is positive for a spontaneous process. What are the only 3 things that tell you if it's spontaneous or not? Which one's positive for spontaneous? What?
Well, I mean, like, Enoch.
Thank you. What letter choice? Letter choice D. Okay, that one's kind of tricky. Remember, E naught must be positive. Which value is positive for an endothermic process? Endothermic process. B. Which value is positive for an increase in disorder? That is C. Its value is positive for a non-spontaneous process. Ooh, throwing a curveball at you. It is A. And its value is negative when the system becomes more ordered. Very good. It is C. Because anytime it's talking about order, it's talking about entropy, which is delta
So
S.
we talked about entropy, you can't get spontaneous state, so use G, K.
Just these three are the only thing if it tells you if it's thermodynamically favorable or not. I highly doubt, if you see that term, I don't think you're going to see spontaneous. Everything in the course description guide says thermodynamically favorable. Okay? H and S only give you indications, not actual. And the reason why, Cannon, is the reason they give you an indication is because when you look at delta G equals delta H minus T delta S, what we're looking for is what is delta G. And there are some cases where if this is positive and this is positive, it has the potential to somehow be a negative delta G. Does that make sense? Because depending on the temperature. Okay? All right, very good. Number one, the reaction where no bonds are broken. If no bonds are broken, what's technically occurring? A phase change. What is a phase? Which one of those up there is a phase change? It is A. Very good. The reaction that has a delta S value closest to 0, which means what is occurring? No entropy change, which means the disorder is staying roughly the same, right? So really, we have no disorder change. Sorry, I keep sliding this over. No disorder change. So that's what's going on there. So if I kind of back, what? That did what? Okay, all right. Well, I learned that from yesterday. Don't do that. So we know that A is a solid to a gas. B is a solid to a gas. G is 2 moles of a gas to 2 moles of a gas. Well, there's very little. We're changing compounds, but in terms of entropy, there's going to be very, very, very little. So that is going to be C. Okay. The reaction that has the largest increase in entropy. So what's becoming the most disorganized? That should be really easy. We've got a solid going to 2 moles of a solid going to 7 moles of a gas. That's a whole lot. So that's D. The reaction that is generally carried out by electrolysis. It is E. How do we split water?
Well, first off, electrolysis deals with water.
Exactly. Electrolysis deals with splitting of molecules. The reaction that represents sublimation. Before you say an answer, what is sublimation? Solid to a gas. What is that? Try that again. Solid to a gas.
Okay.
A. Solid to a gas.
Yeah, so it's D.
Well, we use a solid gas.
But no. It's got to be the same state. All right, you know what? That's a great point. I'm glad you said that. So let's talk about this. What is sublimation? Very good. It is a phase change, which means you're not breaking compounds. That's why it has to be A. All right. Ooh, another galvanic. Good. I wish I could delete this thing. Oh, I can delete it. Good. All right, so the cell is operating. First of all, let's identify some things. We need to know which one's our anode, which one's our cathode. Well, let's look at our reaction. Ni, or nickel, is going from neutral to 2+. So what's occurring with nickel? It's going up, so what is that? That's oxidizing, right? And silver is going from +1 to neutral, so that is reduction. All right, so now let's label our anode and our cathode. Where does oxidation occur? At the anode. So this is our ox and Ra, and this is our red cat Oa. How do electrons flow? Anode to cathode. So they're flowing which way? They're moving left to right. Do you agree with that? What's happening to the silver piece of metal? What do we know about the anode? Anorexic. So what's happening? It's falling off into solution. So what's happening to the mass of the silver? No, the mass of the silver. It's going down, right? So what's happening at the fat cap? It's getting bigger, right? So our mass is increasing.
Oh, it's been forever since we've done these.
But is it clicking?
Yeah, I can feel the dust.
If you notice, we hadn't even looked at a question yet, but we're plugging in the parts. Now, this is the good one. What do we always use as a salt bridge? Potassium nitrate. Now, what part of the salt bridge went to the anode? The anion. Remember, that's where it got its name. The anion goes to the anode. The cation goes to the cathode. Cathode. All right. So now we probably didn't even need this, but we did it anyways, just in case you ever have to draw one of these or label different parts. Matter of fact, last year, the electrolytic question, or the galvanic cell question that they had, it was worth 10 points. My kids averaged 7 on that. Knocked it out of the park just because they knew it really well. This letter represents the salt bridge. That's easy. E. This represents the anode. Remember, listen, anode and cathode are metals. Okay, be very aware. If it says what is the anode or what is the cathode, it's actually referring to the piece of metal, not the beaker, not the solution. So we know it is A. We know that the cathode is B. But bottom line, how were we even able to label this entire thing? You have to know redox reactions. If you don't know that, you can't do any galvanic cell because you would have everything backwards if you can't label oxidation reduction. Okay? This letter represents the flow of electrons. You got to look right. Oops. You got to look right here. It is C. Very good. Why? Because it's flowing which way? Left to right, anode to cathode. This letter represents the flow of ions in the salt bridge. It is D. Remember, ions flow backwards. They flow against because it makes a circuit. Exactly right.
Mr. Richards, are you sure those are the anode and the cathode?
Would I be wrong?
I
Go ahead.
I noticed the first when I was looking at the formula because anorexic.
Holy crap. Did I mess that up?
Yeah.
Yeah.
And going from solid to ions.
Yeah, I just thought I was just losing my mind.
I totally screwed that up.
Why would you want to lose?
All right. So let's.
I screwed that up.
I totally butchered every bit of that.
So, EVADC?
Wow, I'm embarrassed. Like, I am genuinely embarrassed.
You'll get over it.
Let's try this one more time. Like, I'm actually kind of pretty mad at myself. That's not okay. Try this again.
Start over on a new slide.
That's cool. We all make mistakes.
Nickel is going from, I wish you'd have called me earlier, David. Nickel is going from 0 to 2+, which is oxidation. Silver is going from plus to 0, which is reduction. I had that labeled right, but I went down when I drew it, I labeled it all wrong. I'm furious at myself. All right, so nickel is oxidation. So this is the ox and Ra. Wow. Yep. Everything was backwards.
EAVDC.
So this is our red cat OA.
Oh, yeah,
Guys,
that does make sense because how would nickel be getting larger when electrons flow?
exactly. So our electrons are actually going to flow backwards. Guys, if you're watching this at home, please don't punch your computer screen.
Why don't you just delete that slide and just start over? So it doesn't matter.
I'm too far into it now.
How long is it for somebody?
I've broken computers before like that. You should well.
All right. So now I've got it relabeled. Wow. I really apologize. The salt bridge is, again, remember the salt bridge. Then the nitrate's now going to go to the anode. The potassium is still going to go to the cathode. I just had to swap them. Wow. I've never been more embarrassed. All right, E is still right. This letter represents the anode. Remember what we said is anode and cathode are metals. Wow. I'm not going to get over that one. I'm serious. The anode is B. The cathode is A. Flow of electrons would be D. The flow of the ions is C. Wow. Well, that was 9 minutes wasted.
At least you got one more, right?
Don't. This is a lesson. Don't be an idiot.
The only thing that I can think of that's worse than what I did on K, that was reactants over products.
That sounds like something I'd do. All right. Sorry again for the wasted of 9 minutes of your life. All right. Let's look at this one. This is quiz 26. This reaction will always be non-spontaneous. Ooh.
Wouldn't it be C?
I thought it was B. No, wait. No, it is. No, it is
It's
C.
negative, with delta H is negative.
It's C.
I remember.
Oh, God.
I was fighting.
Duh. It's not a unit circle.
I was fighting.
It's a unit coordinate
That's
plane.
what I
Please
was
don't
doing
turn
during
on
access
radios
meeting.
on there.
I did not work on it.
All right. Hold on. I'm totally butchering this thing up. Give me just a second. C.
Negative, positive.
Yep.
Negative.
Yep. Nope.
Yeah, it is negative.
It's always XY. So it's positive, negative. That means I screwed the top one up.
Oh, yeah. Yeah, you did.
Why didn't I catch that? No way.
What else would you be hungry for?
Hungry for revenge.
I'm so hungry for knowledge.
No, I got the rumblings
I'm
that
hungry for banana bonds.
She's got a rumbling brain.
Hungry for a 5.
All right, so here's the case. So if these two things happen, if it's thermodynamically favorable at high temperatures if they're the same sign. It's thermodynamically favorable at low temperatures if they're both negative. So 2 positive means it has to be high. 2 negatives means it has to be low. And I always get this question every year. Well, what is high temperature and what is low temperature? Use your brain. Is room temperature high temperature? No. But if we're working with 5,000 Kelvin,
Don't stand.
what I'm saying is that's got to make sense. Now, what do we know about delta H and delta S? Delta H likes to be what? Delta H likes to be negative. Delta S likes to be what? Positive. So when we look back at this thing, where does that put our always spontaneous?
Always spontaneous.
Yes. Delta S is positive. Delta H is negative.
C.
That puts us in this location right here, right? So this is always TF, and this one is never TF. Think about that. If we know that delta H likes to be negative and it's positive, and delta S likes to be positive and it's negative, neither one are what they want to be.
Wait, are you getting that backwards?
No? Did I get it backwards?
Is it delta H, delta S?
Son of a gun. Damn it. Maybe I should stop. All right, so it is getting bad.
Don't
I
worry.
just break
The
people
last
up.
one, wait, hold on.
Just hold on.
You got this. You got this color makes me hungrier. Why?
All right, so this reaction will always be non-spontaneous. So think about this. H likes being negative, and S likes being positive. Well, which one of these two are going to be opposite of what they want to be?
They're all C.
H likes to be negative. Well, that leaves us at A and C, and S likes to be positive.
Let's see.
Well, so it means it is C.
I still don't understand why S likes to be positive, but for some reason reaction.
Because entropy is positive at the gaining disorder.
Like, for disorder, but then in reaction to for stability.
I agree. That's a good point. No matter the conditions, No matter the conditions, the reaction will always be spontaneous. That means H and S are what they always want to be. H is negative, S is positive. That is B. This reaction will only be spontaneous at high temperatures. That means the signs got to be the same, and it's got to be which signs? Two positive. Remember, positive means high. This reaction will only be spontaneous at low temps. That means they got to be the same, and since it's low temps, it's which sign? Negative, so it's D.
I don't even remember that.
What?
I don't even remember talking about that.
We did.
It was in a big one.
Okay. This reaction is spontaneous due to both enthalpic and entropic values. I don't even know. Which quiz number are we on? 26?
Isn't that the series B?
It is B, yeah. It's spontaneous due to both of them. Okay? We good there?
See, this is why I always want to think that when it's spontaneous, the temperature is always negative.
But it doesn't have to be.
Yeah.
Doesn't have to be. Because and that's I'm glad you brought that up. Just because, so when we look at delta G equals delta H minus T delta S, is there a value that delta G can still be negative, which is thermodynamically favorable, and H can be negative, but this minus T delta S,
It'd have to be a smaller negative.
it'd have to be a really, really, really small negative number, right?
Or just smaller than delta.
Yeah, so there's got to be something we can plug into this to still make it negative, and delta H is negative. Excuse me. No. I'm backwards again. If this number is positive, which means it's not thermodynamically favorable, if delta H is exothermic, which is what it likes to be, right? There's a number that I can plug in to make this thing, that'll make delta G positive. Does that make sense? Okay. I've had a bad day today. All right. In the reaction mechanism below, first of all, remember there's two things. Number one, it's the overall reaction. And number two, it's the slow step. And what? And above. Do you agree? So if I did the overall reaction, what would it be? C is going to cancel, right? So I've got A plus. Ooh, what else cancels? See, I'm bad again. All right. A can't. Sorry, let me do it blue. A cancels out, and that leaves me with 2B yields what? Well, yeah, I'm going to do it this way. E plus D, same difference. So that's the overall. What would the rate law be?
E squared, or KB squared.
Rate equals the rate constant, B to the second order. Remember? Okay. All right. Blank is the catalyst. Now, what do we know about catalyst? It's a reactant, and it goes to a product. So what is it? It is A. Very good. The reaction intermediary. Oh, that's a good one.
Wouldn't that be C?
Remember, intermediate goes from product to reactant. So that is C. The reactant in the overall process. That is B. The product that does not act as an inhibitor in the process. This is a good question. The product that does not act as an inhibitor. What is it saying there? Which one is not the slow? Because what does an inhibitor mean? It slows it down. So which one of those is not the slow inhibitor? It is D. Very good. Okay? And then the inhibitor in the process is always the... It's always the slow step. But...
Nice confidence.
Hold on. Are we on the second part of this?
Yeah.
We're on quiz 26?
Yes.
The last answer?
Yes.
Did I get these wrong?
What'd you say?
Oops. Again, I got these backwards. It says E then D. Which of these does not act as an inhibitor? I disagree with
It's
this.
not helping anything. just throw it in there and then it disappears after that.
Yeah. I disagree with this.
We should riot.
Well, let's burn down our city.
Yeah.
Grab the pitchfork.
Yeah, that's I
Have fitty pitchforks.
I disagree with this.
These are the fastest.
Yeah, I disagree. I think it's D then E because an inhibitor is the slow step. But my question is it B or is it E?
Grab your torches, sharpen your pitchfork.
All right, next one. 27. Didn't we just do this one?
No.
Same concept. Delta G will always be positive no matter the conditions. If delta G is positive, is that TF or not TF?
Not.
That's not TF. So that means H and S are not what they want to be.
Which means it's
It's C. Delta G will always be negative, which is what, TF or not TF?
very much.
That is TF. So that means H and S are exactly what they want to be, which is B. Delta G will be negative at low temps. It's got to be, they're the same, and since it's low, it's D. Delta G will be negative at high temps, means they're the same, so it's positive because it's high temp, so it's A. And delta G will be negative due to the value of the entropy.
It's either C or D.
It says it's A, but I don't,
What? Or A or B.
I mean, I guess if you're neglecting.
because it's right here, it's got to be one or the other. That doesn't make any sense either.
They never make sense.
Okay. Like this is the exact same thing we just did.
It kind of is.
It's a little different. All right, so let's do it again. So,
This is still the same.
all right, so A cancels out, C cancels out, giving us 2B going to.
Same thing as it was.
Questions are a little different. Blank is the catalyst. A, the reaction intermediary. C, in the rate law, it will have an order of 1. What?
That's not even possible. Cancel out.
Oh. All right, this is something that we never. This is something we hardly ever covered. Can a catalyst be in a rate law?
I guess I'll have
Based
to.
on.
Yes.
Yes.
Here's the reason why. Because remember, when we do the rate law, it's from the what and above? The slow and above. But what is the only thing that's in a rate law? The reactants. So what's going to cancel out? The C is going to cancel out. So if we wrote it, it will be rate is equal to baby K, A to the first,
B squared.
and then B squared. So this is A. What would have an order of 2? That would be B. And what will have an order of negative 1? What? Are you kidding me?
How's that even possible?
It's D. And I don't know why. It is, yeah, it's F. We're going to go with F.
D's not even.
There's no such thing.
I know.
Oh, gosh.
How many of these are there?
30. We're on 28.
Of ones like this?
Isn't this the exact same thing?
There's one more of that kind of format.
We're going to skip the top one. I'm tired of it. All right. Blank. A graph of ln versus time would be a straight line for these species. So if it's ln versus time, what does that mean? It's first order, right? Well,
I have a question.
go ahead.
You said spontaneous reaction is driven only. Is that the same thing as like it's thermodynamically favorable?
Yeah. All right. I don't know. So ln versus time is first order. Will we just determine that A is first order? All right. Let me double check. We're at 28, right? All right. Are you kidding me?
The graph of Ln versus.
This makes. Are we on? Oh, okay, never mind. I'm right. I was looking at the wrong one. A graph of the 1 over the concentration. What does that mean? Now, what order is that? That's second order. So who would that be? That would be B. In the rate law, this species will appear in the denominator, which means to the negative first power. So I'm hoping that's going to be D. The reaction intermediary, C, and the catalyst, A.
You
We good?
It would change this up after.
I would hope so. But if you notice, they're all different, and they're asking different points of emphasis.
Well, they've asked what is the catalyst like 3 times.
But that's okay.
Hey, that's just more points for you.
That's right. All right, so given the reaction of this at the top, delta H is positive. Predict the effects that each of the following changes will have on the given values. If you decrease the container size, and let's talk about that. If you decrease the container size, what else is that affecting? All right, so you're decreasing the volume, so you're increasing the pressure. And how does Le Chatelier deal with increasing pressures? Very good. So we're going to shift to the least moles of a what? Of a gas. All right, so look back up there in your reaction. How many moles of a gas do we have on the left? 1. How many do we have on the right? So what way are we going to go? We're going to go towards the reactants. Okay, so that means that N2O3 has to go up or down? Up. So that means what's the only possible choices left? A, B, and E. Now, look at the very far right one. Which one can we knock off now? What? No. The last one. Why B?
Because the only thing that changes K is temperature.
Very good. The only thing that changes K is temperature. So that tells me these two right here have to have a temperature change with them. Okay, so B's out. Now, NO and NO2 are going to do what? Decrease. That leaves us the answer of A. Very good.
So, but you couldn't take E out automatically because one of them decreases and the other one decreases?
Sure.
Good.
Okay. Adding NO. So we're adding a product. So what way are we going to shift? All right, so we're going to the reactants. Hello, what's the answer?
A, B, or D. Probably A.
This one's kind of a tricky one. Why is it E, Parker?
Yeah, that's probably because you're adding NO.
You're actually adding some NO, so it has to go up a little bit. That's got to make sense, right? 3, lower the temperature. Now, what is temperature based upon? It's based on delta H. Now, in this problem, delta H is positive, which means it's endo, which means the heat goes where? The reactant side, so it's plus heat. And we're lowering it. Now, since we're lowering it, what way do we shift? Towards the reactants. And so that means what has to happen to K? K changes how? Because the reactants go up. It's got to go down. Why? Because reactants are in the denominator. So what has to be the answer? Has to be B. All right. You decrease the external pressure. Ooh, that does.
Nothing.
If you increase the external pressure, what happens to the volume of the container?
Does it get a little bit bigger?
This is a good one right here. If you decrease the external pressure, if you're talking about a balloon, the volume goes up, which means the pressure goes down.
The internal pressure.
The internal pressure goes down as well.
That's weird.
That is weird.
So with the external pressure, the internal pressure.
So if we're decreasing the pressure, how do you shift?
To the
Most moles of a gas, right? So this way, what time are we shifting? Towards the products. We know that K is not going to change, right? So that knocks out B and C, or B and D. So decrease, increase, increase. Yep. So it's got to be, what'd you say? C. Very good.
Do they have a lot of these like matching types in there?
Kind of like this, yeah. All right, we increase the temperature. All right, we go up, we increase, we shift towards the products. Now, K has to change, right? Since we're shifting towards the products, what does K have to do? It's got to go up. So that makes the answer automatically
It's gotta be
D. Stop it.
That was the Captain D's commercial.
All right, so let's move on to this one now. This is a titration. I think this is a really good one to look at. Now, what are we starting with, and how do you know?
I think that's a base.
It is a weak base. Why is it a weak base?
It's less than 12.
Very good. It's less than 12. And what did we start with? Matter of fact, let me...
Can't really tell. I think so.
Okay, all right. So we're starting with a weak base because it's less than 12, but it ends at about 2.
Yeah, so it is.
It's a strong acid. So the first question, which point are the number of moles of acid and the number of moles of base equal? What do we call that point? Equivalence. Wow. Equivalence
It's done.
point. When is the equivalence point achieved on the graph? It is halfway between the two vertical points, which is what? D. Where point? Which point or what point represents the maximum buffer action? It's between those 2 points, I think. Which one are we on? We on 29?
Yeah.
All right, it is B, which is what I thought. The buffer zone is halfway between the initial and when it begins to start verticalizing. Ooh, that's a good one. Yep, it's halfway between C and A. So it is B. What point can be used to determine the Ka of the conjugate acid? Remember this. The pH is equal to the pKa at the half equiv point. All right. First of all, where's the equivalence point? D. Where's the half equivalence point? B. So if I know the pH, it's the negative log of. Exactly. So let's say the pH is 8.2. Well, what is the pKa? No. It is 8.2. So how do I find the Ka? It's the exponentiated negative 8.2, right? Okay. All right, so that is going to be B again. What point represents the half equivalence point? Half equivalence point. It is 3 B's in a row. At what point represents the equivalence point? D.
That's really bothering.
Well, let's talk about it. What is A?
The concentration.
It is the concentration of the weak base initially. C, I don't know if it has a point. And what is E? The concentration of the strong acid finally, right? Okay. All right. Do we really want to go through another Le Chatelier? Well, this is the last one, and we're definitely not doing 6 through 10. So let's do this, and we're done forever with AP Chemistry.
No, man, I don't know what you
We
talking
get the
about.
exam Monday.
That's test on Monday.
What?
Then we'll be done.
I don't know what that bottom part is, so we're just gonna skip it.
What kind of graph is that?
Wait, so we're not.
I don't know. All right.
Temperature versus.
So H2 plus Br2 is in equilibrium with 2 HBRs, and then notice this. Be very careful here. Listen. It says plus 68 kilojoules. Now here's the problem. Just because it says plus in this reaction, is it endothermic? No. It's actually treating, it's like saying plus heat. So it's actually treating this one as exothermic. Don't let them fool you.
I would do that.
Look for delta H. If delta H isn't there, look where it is in the reaction. Be very careful with that, okay? They may throw that at you. So this is actually acting as exothermic. All right? If we decrease the container size. Now, we just talked about that. If we decrease the container size, we increase our pressure. And so how do we shift from an increase in pressure? Very good. So we're going to the fewest moles of a gas. But there's a same. So nothing happens. So what answer choice is that? It is E. Very good. Nothing happens. All right, if we add Br2, we're going to go towards the products. But what do we know about Br2 as well? BR2's got to go up, right? So it's got to be C. Very good. If we lower the temperature, now remember this is exothermic, so we're going to take some temperature out, so we're going to shift towards the products. But if you change to T, what else happens? K changes. Now we're shifting towards the products, so what has to happen to K? K's got to go up. That automatically makes what the answer? Automatically B. We decrease the external pressure. All right, so that means the volume's got to go up and the pressure on the inside's got to go down. So we shift to the most moles, which is neither. So what's the answer again? It is E again. And then we increase the temperature. Yep, so that knocks those out. So if we add to this side, we shift towards the reactant. So what has to happen to K? K's got to go down because we're going towards the reactants. That means it has to be A. Yep. And guys, you are finished with AP Chemistry.